Let's take a look at slope and average rate of change. So remember that with slope, we have to have a linear function. We can find the slope of a line because it is rise over run, or that ratio of the vertical change to the horizontal change in a linear function. When we talk about average rate of change, that's the slope of a line that connects two distinct points on any line or on a curve. So now we can have an average rate of change that is not necessarily for a linear function. So let's take a look at what that looks like. So remember, when you have slope, you have to have a straight line. But when you have average rate of change, you can do that with a quadratic, which gives you a parabola. Or you could do it with an exponential function or a periodic function, lots of different types of functions, not just linear, okay? But the process is really the same. You're finding the change in the y values over the change in the x values, the change in the y values divided by the change in the x values. So you can see here, and it's a little bit fuzzy, but the slope of this line that connects the 2 points, see how these 2 points are connected by a straight line, is really just f of b, which is the second ordered pair here. If you have b, and then you have f of b, which is that y value, and then here you would have a and f of a, right? So you're taking the change in the difference between f of b minus f of a, and you're dividing by b minus a. So it's really just you're finding the slope. So the easiest way to look at this is to connect your points with a straight line and then just find the slope of that line. Okay, so I'm going to connect these 2 points with a straight line, and then I'm just going to find the slope. All right, so remember, we take our second y value, the one that's farthest to the right, so -6, and then we subtract the other y value, which is 3, and then we divide that by 3 minus 0. So -6 minus 3 is -9, and 3 minus 0 is 3. So -9 divided by 3 is -3. Pretty easy. Okay, now we're going to take a look at the second one. And so again, I'm going to connect them with a straight line. And then I'm going to take the difference in my y values. So the second one is 6, the first one is 0. And then the difference of my x values, well, the -2 was with the 6, so I have to start with that, minus, and then -8 was with the 0. So 6 minus 0 is 6. And then -2 minus -8, that becomes +8. So that gives us a -6. No, that's a +6, which gives us 1. Okay, let's take a look at the problems on the back. Okay, so why don't you go ahead and try the first problem. Pause the video, try the first problem, and then come back and check your work. Okay, so I drew my line to connect the 2 points, and then I took the difference of the y's over the difference of the x's, and that simplifies to, or that gives us 9 over 3, which simplifies to 3, so the average rate of change is 3. Notice that our line is going up from when we read from left to right, so we do expect it to be a positive number, and that's a pretty steep line, so it should be 3. That does make sense. So we always need to ask ourselves, does our answer make sense? So go ahead and try number 2. Find the average rate of change between the 2 points for number 2. Pause the video, and you try it, and then come back and check your work. Okay, so again, we have connected the 2 points with a straight line, and then we looked at the difference of the x's divided by the difference of the y's. So we got -6 over 6, which gives us -1. Again, when we read from left to right, we do have a line that goes down, so we do expect it to be negative. And the slope is not too steep and not too not steep, whatever the opposite of that is. So -1 does make sense in this problem. So go ahead and do problems 3 and 4, and then, and that should say 4. This doesn't say 4 here, it says 2. That should say 4. And then go ahead and when you're finished, you can check your answers with the teacher.